Hi, my name is Silent Dad. This video will contain solutions for the exercises in the C programming language book by Kernighan and Ritchie. Exercise 1-22. Write a program to fold long input lines into two or more shorter lines after the last non-blank character that occurs before the end column of input. Make sure your program does something intelligent with very long lines, and if there are no blanks or tabs before the specified column. Okay, so again, similar to the previous program, we're going to process the input per character. So, but first, let's create the template. Okay, now that we have the template, so let's create let's define a numeric constant for the end column of input, and we're going to call it the column width. So define and say 80, so that is the column width. Since we're going to need an array onto which to save the input, let's define size of array max as 1000. Size of array. Okay, so let's create some sort of a algorithm or procedure. So first, we're going to process the input per character. So let's going to save the character in the array. If column variable, if col is equal or is greater than n, set the character in the array. So this is the input per character, and then we're going to save the character in the array. And we're also going to keep track of the call variable, which is the column of input. If call is equal to or is greater than n, we are going to insert save a new line character into the array. And we're going to reinitialize so let's create an algo. So while there is an input or there is a character, save the character into the array. Check if column is greater than n. If true, save a new line to the array. So let's try to create the code for that. So int c, c is equal to get car. Okay. So when c is equal to get car, si save the character is equal to c, increment the increase, increment the column variable, of course. So I call I is equal to 0, call is equal to 1. Character as max. Okay, so if call is greater than n, si is equal to new line, increment I, column is equal to 1. So that's basically it. Okay. But we're going to reinitialize column also to 1 if the character is a new line character. So if C is equal to new line, call is equal to 1. So if the character is equal to tab, okay, no. So the value of call will depend on the value of new line character. So of the character. So if C is equal to new line, call is equal to 1. Else if C is equal to tab, if C is equal to tab, we're going to set the value of call to set the value of call to the column immediately after the nearest tab stop. Okay, so to find the nearest tab stop, we need okay, so we're going to assume the tab stop to be 8. So define tab 8, tab stop size, tab stop size. So the nearest, so knowing from the previous since a tab stop will always be a factor of the tab. Every tab stop is a factor of tab. We're going to find the factor first, just like the previous exercise. So x is the factor. So so find the factor. Since every tab stop is a factor of tab, find the factor. So assume tab stop is equal to 10. So if column is greater than equal to 1 but less than equal to tab stop 10, x is equal to 1. So if 20 is equal to 2, so in general x is equal to col minus 1 divided by tab plus 1. So now that we have the value of the factor, okay, so let's compute. So x is equal to col minus 1 tab plus 1. So the tab stop is equal, the column will be is equal to x times tab plus 1. So let's include the variable x. Now else increment call. Okay, now that we have this, okay, so at this point we now have the input, we now have the modified the saved input, so we can now print similar to the previous exercise or previous exercise 1-20, 1-21. We can print the modified input when our array is full. So if I is equal to x minus 1, so let's add a new line, a null character at the end, because that will be needed by our printf function. Set I is equal to 0, of course. Okay, so let's modify input after when the array is full. Okay, so we're going to do the same. Modified input, the remaining input. So going to add again a null character at the end, then going to print. Okay, so I think that will be all. There is one problem here. What if at the end of the input it okay, the last line, the last character of a line falls to the exact number of column, meaning right after that character is a new line character. So since we're going to insert a new line character in the array when our column when we reach the specified amount of input, so on the next iteration, on the next reading of the character will be a new line character, so an excess new line will be printed before the uh, it says new line will be printed on the output, will be printed because we have inserted already a new line when we reach the specified amount of column input, when our input falls exactly at our specified column. So we're going to add a special condition on that. Special condition uh, uh, if that occurs. So increment I, so if also, how do we do that? Okay, let's get a character c is equal to get char. Let's call the get char function. So if c is equal to new line, we're not doing anything. Else we're just going to copy the character to the array if it is not a new line, so that our code will not break. Okay, let me see. Wait, let me look at the logic. If it is set column is equal to 1. Now if it is a new line, else just copy the character, increment I, and increment column. Okay, so now that we can, let's try to compile and see the output. Okay, so let's feed its own source. Let's feed as input its own source. Oops, no. Okay. So let's look. Let's change this to 40 so that we can see what really is going on. -92. Okay. Look. So how do we know if it is correct? So there is a program which is part of the GNU Core utilities which does the same thing as our exercise, and that program is called fold. So let's get the man page for fold wrap, and the fold says that it wraps each input line to fit in a specified width. Okay, so let's try. Okay, so let's try to so let's create again, let's feed again our output, let's feed again our input line, our source file to our program, and let's create an output file. Let's call it output file. Then let's do it again with fold, but this time using 40 as the width and that's 22, and let's let's call this output. So let's compare our output file with fold. So they should be the same. So this is the output of the output file of our the output of our program. This is the output of our fold. Very different. W40 1-22. And let's try again. 22 out. My output for W40 fold output. So let's begin. Okay, so let's try to do a side-by-side comparison. This is the output of our default program, and this is the our output of our program. So at this point, almost the same. Let's start at line 47, line 41. At line 41, still the same. Okay, from line 88. Okay, so it's still the same. So one way is to pipe it with WC. So fold, pipe it with WC. They should have the same. They should have the same output. Okay. So okay. So another requirement of the program is make sure the program does something intelligent with very long lines. So since our max is 1000, we cannot see a very long line of input. So let's try to reduce this max to 10, so that we can let's reduce this max to, let's say, 20 to check. So we should be getting the same output as before. So 89 minus 22. So the same output should be, we have the same output as before. Oh, stack smashing detected again. Stack smashing because if there is an expression that increments the index of an array, there will always be a possibility of an overflow. So let's include some sort of a buffer flow overflow check. So if I is equal to 1, so let's call this the buffer overflow check. And let's include another buffer overflow check here also. Not buffer, array overflow. Okay, we don't need to put a buffer flow check here because it will be checked. It will be checked. The check will be performed here. Okay, so let's try again. Okay, so let's feed again on input. Stack smashing shouldn't be, will not, there's no stack smashing. Okay, so let's use this window so that it's much bigger. 1-22. Okay, so let's try to pipe it into WC. Let's see, it will have the same output when we use the fold application. So 1-22C, pipe it to word WC word count. So fold W40 1-22, pipe it to WC. They should have the same output. So okay, so we can safely assume that our program is correct based on this output comparison using the fold program, which is part of the GNU core utilities. Okay, so that will be all for now, and I hope you learned something.